Okay, so at the top there, it's just asking you, does this factor? Um, if we try to factor this one, we're not going to do that too much. This whole little change, or the number 2 in front of that x squared, is not something we really have dealt with. And in this case, it wouldn't factor anyway. So that's not going to factor. So if I ask you what your x-intercepts are right now, we wouldn't know that. Normally what that means is we're going to factor it, set that equal to 0. Whatever sets it equal to 0, that's going to be your solutions. All right, your solutions and your x-intercepts are the same thing. Well, when this doesn't factor, so when the answer to the factoring question is a no, one of the ways that we can solve it is what we were doing yesterday, and that's that little quadratic formula. So if you need to, I'm going to write it up here so I have some room to operate. But the quadratic formula, the x values that you're going to be searching for, so our x-intercepts, was the whole little negative b, and then you're going to have your plus minus square root of b squared minus 4 times a times c, and then all over 2 times a. The A's, B's, and C's, all those variables we get from this equation, as long as this is in standard form, which it is. Standard form means you have your x squared term, and then your x to the first term, and then the no x term in order. Those are your A's, your B's, and your C. So for this question, I'm going to label these again. A is the 2, all right, because that's the number in front of the squared term. The B is a negative 8, because that's the number in front of our regular old x. And then the C is your constant, and that is the positive 5. From this point on, it's really just a formula. We have the formula. We know what each letter means. You're going to plug that in. Now, there's a lot of things that can kind of happen here that make these involved. But initially, once you have those identified, we're just plugging in what those values are into the appropriate location. So for the first one, the whole little negative b just means whatever the b originally is, and it's a negative 8. When we go to plug this in, it should become a positive 8. Then you're going to have your plus minus. And then we want to square whatever b was. So b is the negative 8. So we want to square that. And then you have your minus 4. And then you multiply by a, which is a 2. Multiply that by c, which is a 5. And then all of that gets divided by twice the a value, which is 2 times a. So it's messy at the beginning. It's messy for a little while because we now need to go through a bunch of steps to clean this up, simplify this as much as we can. So once that's substituted in, that's your process. We want to now just go through and clean this up as much as we can. So the positive 8, can't really do anything with that. But underneath the radical, we have a few things we can do. The negative 8 getting squared means I have a negative 8 times a negative 8. So that's going to be 64. And then, like I mentioned yesterday, where you really want to be careful at these, even when we do a little quiz on Friday, when we've been now doing this for a little bit, and we're better at it, and we've seen plenty, is the sign here. This is going to be the biggest mistake I see. So just be careful with that sign. I'm multiplying all 3 of these numbers that I have highlighted in yellow together. So when I initially do a negative 4 times 2, that's a negative 8. That negative 8 then gets multiplied by a 5. So a negative 8 times 5 is a negative 40. So that would remain a minus, and then you should get 40. And then in your denominator, you're going to get a 2. All right. From there, we got to continue, simplify that as much as we possibly can. So underneath the radical, we all know 64 minus 40, pretty simple, is 24. And then we still have the 4 in our denominator. One we did yesterday, this is a nice perfect square. The other one we did, it was not a nice perfect square. 24 is not a nice perfect square. So what you are then left to do is we just need to simplify that 24 by, again, finding those 2 numbers that multiply to be 24, but add up, or I'm sorry, multiply to be 24, but one of them being a perfect square. All right. That should be nice. All right. Armando, what is that?
4 and 6.
Good. So 4 and 6 are those numbers. The reason that then is nice is the square root of 4 we know to be a 2. And then over our 4. And then now two things. If you leave this as your answer, so this is kind of a open-ended, write your answer down. This is correct. Like I would take this. There's nothing wrong with this. However, on a multiple choice, when we eventually get to our test where you're going to get some multiple choice questions, that can be simplified, and I would definitely simplify it. The way this can be simplified, look at the 8 here, the 2 here, and the 4 here, all the ones that are not radicals. What is a factor? What's the biggest number that goes evenly into an 8, a 2, and a 4? 2. So what that allows us to do is reduce all of these. So if I did 8 divided by a 2, it reduces this guy down to a 4. The 2 into a 2 reduces that to a 1. The 4 reduced by 2 makes this a 2. So the simplified version of this would be 4 and then plus or minus a 1 root 6 all divided by a 2. All right. That's how I would leave it. We did say yesterday, if you wanted to, you could write this as two separate answers. One of those answers would be 4 plus the root 6 divided by a 2. Oops. And then the other one, if you wanted to, would be 4 minus a root 6 divided by 2. But that's how we get two different answers. Is the one is going to be added, the other one's going to be subtracted. I don't need you to do that. Once you have it written like this, that can be your final answer. Okay? So those then are your x-intercepts. So if I come now over to the actual question, when it asks you for your x-intercepts, we couldn't get those by factoring, but we could have gotten them with the quadratic formula. So that's now what you're going to write over here. The 4 plus or minus a root 6, oops, that's not 6, divided by 2. Those are also considered your solutions. Your x-intercepts and the solutions are the exact same thing. All right, but we can now answer that once we do the quadratic formula. Okay. All right, so again, some more messy stuff here with all these radicals. You're making your way to my room too often these days. Jeez. Okay, I got them both. Thank you. Oops. All right, next one. Next one asks you to complete the square. So do that. Go to number 3 here. Complete that square. We did this yesterday. So it says complete the square and then identify your vertex. So do that part of it. I go now, Jake, so you can get back. And then we'll see if we wrap up on this. Okay, let's see what we got here. So if you wanted to complete this square, again, when we start talking about completing the square, the little square model is nice. A lot of us still use it. So if you're still using it, don't feel like you're the only one. Perfectly good way to kind of approach this problem. We know we have an x squared. We know if this is a 10x and it's got to be a square, that those have to be split evenly between these two corners, making each of those a 5x. So what we know is we have x's here, we have 5's here. All right, so Jada, what completes this square right here? Sort of. You're multiplying, right? Yeah. So this is a 25. So that's going to make this a perfect square. But when we do that, we now hopefully realize we've got to subtract the 25 that we just created on the back end. So that what we end up with is this is an x plus a 5 on the top. It's an x and a positive 5 on the bottom. So this is x plus 5 squared. We end up with a negative 26, and then that would equal a 0. All right. If I now ask you what the vertex is, we can say that's a negative 5, negative 26. So we know that. So we've done the first two parts of this problem. I asked you to do a bunch of things in this problem. So this one is asking you to complete the square. We've done that. If I ask you to identify the vertex, it's a negative 5, negative 26. I now ask you to solve this for the value of x. This was our last quiz. So this is the quiz some of you just got back for your corrections. This is the one that we just talked about. If I ask you to solve that, remember our steps. I always wanted you to isolate the square term. We want to get this guy all by itself. So in order for us to do that, we would now want to add the 26 over, so that I get x plus a5 squared equals a positive 26. Then, once we have it isolated, the reason we isolated it is so that we can get rid of the squared term with our square root. So then we would take our square root, and then we talked, whenever I take that square root, that is the step where I should get my positive and my negative sign. So on the left, I end up with x plus a 5, and then I get a positive or a negative root 26. The 26 you may want to try and simplify. It's a fairly large number, but if you think about the way you get 26, the only combination that would ever give us a 26 would be 2 and 13. That's the only way you would ever get that. Are either one of those a perfect square? No. So that's actually nice, because that means you can't really do anything more in terms of simplifying this. So what we would then end up doing, here's how I want you to write this one out, just so it's going to look the same when we do our quadratic formula. We could definitely set up two different equations. Okay, so you don't necessarily need to do that. Don't do this right now. But just so you understand what we have done in the past, we could definitely set up these two different equations. The x plus 5 equals a root 26, and then a negative root 26. And then notice how we would subtract this over. So just the same exact thing we just took our quiz on last Friday. And we're going to get these answers. However, instead of doing that 2 times, what we could do to make this a little bit easier, and then it's going to look like our quadratic formula as well, I'm going to subtract 5 right away. That's going to cancel. And the way we can now write this, I'm going to put this first right now as a positive negative root 26, and then I would just say minus a 5. All right, that is how we could write that. It's still 2 answers because of the positive root 26 and a negative root 26. But this is the answer to that question. There's 2 answers there. All right. So that is a third way that we have solved these equations. The last thing I then want you to do, so now I'm going to give you a few minutes to see if we can do this, because by now our 4th quadratic formula, see if we can do it. I now want you to, underneath this, so let me recopy this. This was x squared plus 10x minus a 1 equals a 0. Now in the space underneath here, so notice we left you a lot of space, use the quadratic formula to solve this. So identify your A, identify your B, identify your C, plug it into the formula, do that process. Let's see if we can get all the way through one. You know you did it right because we're solving the exact same question. You better get this answer right here. So you better get the same thing that we just got when we used the square root method. All right? And let's see where we are at with all of this stuff. this equation for, plug it into that formula, and we should get the exact same answers. Okay. Yeah. First should be possible. All of the that's a negative 46. Erase this and go with this. This is now same. You know, alright, so this is one thing we agreed on here. Also, this is a -4. Always, so you're actually -4. Yeah, try to number it down, or one. Try to break down. We're going to butter formula, we're going to start it with like finding your days. See. Okay, very good. This is good. This is good. You're good. Here, simple formula. You're close, but just a little. Again, remember I'm always highlighting these four. 0, 6, 6, this is negative 4 times 1, which is what? 4. And negative 4 times negative 1. So this becomes positive. That's the formula. We got more to do with this. Okay, we're getting there. There's just a lot of stuff. There's a lot of steps, a lot of things to be aware of. Here's your formula: negative b plus minus the square root of b squared minus 4 times ac all over 2a. So the b is always the number in front of the regular old x. So b in this case would have been a 10. So since I want the opposite of whatever b is, that means in this spot here, I should have a negative 10. So since our b was originally a positive 10, in the formula it becomes a negative 10. The next thing is also your b. So if b is that 10, I'm going to replace b with a 10, and I now have 10 squared. Then you're going to plug in for your a and your c. This is all one big product, 4 times a times c. The a is the number in front of the square term. That's this 1. The c is the constant at the end, which is a negative 1. All right. As we now go to simplify, and then in the bottom, this is 2 times a. So if this is a 2a, your a is that positive 1. So you're going to put an a right there of 1. When we go to clean this up, most everybody who got this started had the negative 10. We knew 10 squared is 100. And then I've been saying it, and I saw it 3 times kind of walking up and down these middle couple of rows. Be really, really careful with this sign right here. Like I said, this is going to be the place, even as we get good at these, and we are used to this, where I'm going to see the biggest number of mistakes, is with this next sign. So you're multiplying all 3 of those together. So what is a negative 4 times 1 initially going to give you? Negative 4. But I still need to take that negative 4, multiply it by another negative 1. So what's a negative 4 times a negative 1? Yeah, positive 4. So this ultimately becomes a plus 4 in here, a positive 4. And then all of that gets divided by 2. All right. So this sign again here, be really, really careful with it. If you got a 96, then you've had that off a little. Okay. And again, it's predictable. It's normal. We just don't want to continue to do that. So the next step, what we end up with is the square root of 104 divided by a 2. It's not an obvious one. I don't think we've done this one yet, but 104 is a pretty big number, pretty realistic chance that we can simplify that a little bit. So Omar, what numbers did you find that would allow us to break down 104? Good. So 4 is our perfect square, and 4 times 26 would give us that 104. So from that step, we get a negative 10 plus or minus a 2 root 26, all divided by 2. If this was an open-ended question on a quiz, like we'll take a little quiz on Friday, if you left this, I would take this. There's nothing wrong with this. Okay, I would take this answer. But on a test, if it's multiple choice, you need to make sure that you also know how to reduce this. And then also the same thing I said up here. This should give us the same answer that we got doing it the other method. Right now, it doesn't look like it is. But if you understand now how this plays out, remember what we talked about. If all three of these numbers that are not underneath the radical have a common factor, we can reduce all of them. So between a 10, a 2, and a 2, what goes into all three of those? Armando? 2. So all of these can be reduced by a 2. So a negative 5 reduced by 2, or negative 10 divided by 2 is a negative 5. The 2 reduced by 2 is a 1. So then we just end up with a root 26. And then right now I'm going to put the fraction bar right here. But on the bottom, isn't 2 divided by 2 also a 1? So we don't really need that denominator there. We'll keep it. So now let's compare our answers. So if this is what we got using the quadratic formula, is that the same thing that we got by doing the square root? Yeah. All right. The order is flipped around, but you have a positive and negative 26 in both. You have a negative 5 in both. Those then are equivalent to each other. Okay. Okay. Last thing, go to number 2, whatever the next problem. I don't want to move this. Some people are, well, is it number 4? Don't worry about the factoring. Don't worry about all that stuff. Just do the quadratic formula in number 4. I think it's the last one on there, right? So see if we can do that, and we'll talk about that. So see if we can walk out of here, hopefully getting one of these quadratic formulas correct. So don't worry about everything else I ask. Just use the quadratic formula to answer number 4. figure out. So in the lab, we didn't do it initially. So in this one here, well, we did reduce. Notice I didn't do 2 and 26, right? So otherwise that would become 13. So it just become 13. So I had a number of non-actual zeros. We had that in this problem. We had a denominator square in this problem. See, we have a number out in front of it. Once you simplify this, if you're using the change it out to 1, or you need your forwards. Okay. Beautiful value. Now, I tried to reduce that. So again, giving this on homework time, giving this on quiz, and it's not reduced. I'm not marking it wrong. But this doesn't use it. Okay. That's your power. So that's one you factor out, takes this down to 8. So it's actually there. So this is the one. Okay, very good. Okay, the first 3 or 4 steps, everybody is looking pretty good. Then it's the very end where it's a little bit harder. This is your A, this is your B, this is your C. Then our formula is a negative B plus minus that square root of the B squared minus 4 times A times C all over twice A. So if B is a negative 16, when I plug that in, that should have become a positive 16. All right, most of us are doing that fine. Then the B gets squared right here. So I'm going to take this B and I'm going to plug in the negative 16, and then that gets squared. Then I do 4 times A times C. A is a 2, C is a 6. So we'll do 4 times 2 times 6. And then in your denominator, that's 2 times A. And then 2 times A in this problem is 2 times a 2. The substituting looks pretty good. Walking around. Now you're going to get negative 16 squared should have been 256. When we multiply all those together, you should get 48. All right. All of that gets divided by 4. Underneath that square root, when we went ahead and, again, you have your calculator at your disposal. Use it if you need to. Oh, goodness. What is that? 208. All right. Is that all we got there? All right. And then all that divided by 4. Then this is a pretty big number, pretty reasonable chance that we can come up with some perfect squares. They're going to multiply to be a 108. All right. And there was. All right, Ben, I think you had them. What was the 2 numbers that multiplied to be 208 with one being a perfect square? Good. All right. So maybe not obvious. You may have to punch around your calculator a little bit, figuring that out. But 16 and 13, multiply those together, give you 208. 16 is our perfect square. So I get a 16 plus or minus this square root of 16. We know that to be a 4. And then all of that is divided by the 4 in our denominator. And then like I told Ben, because this is what Ben had, if this is a homework question, if this is our quiz and it's open-ended, this is right. There's nothing necessarily wrong with this. However, it can be reduced. So if it was a multiple choice question, it wouldn't look like this. It would be reduced. So we want to understand how we can reduce this. So like what we talked about, as long as all these non-radical terms here, so the constant in front, the number in front of your radical, and your denominator all have a common factor, we can reduce all of them by that number. So now what is the biggest number that goes into 16 and 4? Caden? 4. So all of those are going to get reduced by 4. So what is 16 divided by 4? 4. So that number comes a 4. What's this 4 divided by 4? A 1. And then in our denominator, again, 4 divided by 4 is a 1. This is our reduced version. In fact, because it is a 1 in our denominator, we wouldn't even need to write it. This would be the answer that you would be looking for if it were multiple choice. Okay, and if you got that, that's really good. Okay. All right. Tonight, you don't get off the hook. No homework tonight. Okay, on this, just so you don't do too much work. Numbers 1 through 4, they tell you to complete the square. I don't need you to do that. All I want you to do in 1 through 4, just use the quadratic formula. So just get used to cranking out a bunch of quadratic formulas. I don't need you to do that other part of it. Same on the back, 5 and 6, I just want you to use the quadratic formula. Right, so that one's a little easier, but just all of these quadratic formula only. All right, 1 through 6. All right, and I'll grab this tomorrow and see how this goes. And I recorded this too.